Okay, so this is the object 2005 QQ87. So what I'm going to do here is just show you how this can be solved without running the tracker. So this is the object in question. I'm going to download observations, and I'm going to click here to attach ephemeris of this object for this particular data set. In other words, each image will be assigned the coordinates of the object as it is for that image. So I'm running the find orb software over here, and it is computing the orbit of the object and then the ephemeris. So this takes a little while because I guess this orbit is somewhat more complex than others. But anyway, okay, here it is finished, and as you can see, we now have these columns populated. So for example, here's the right ascension, here's the declination. And in this column here, we can determine whether or not the object is in the field of view for that image. So I'm going to go here, and you'll note these last images here, the object is not in the field of view. So I'm going to go ahead and remove those images from the data set. Okay, now that I've done that, I'm going to go ahead and view the images. So yeah, you'll notice we can do this again all without the tracker. So first off, what I intend to do, let me go ahead and adjust that, is select the first 1/3. So we're going to create 3 stacks of observations. So I will create the first stack here, and this is the normal behavior, crowded star field, so you can't hardly see the object. But if I switch here, ABV layer, and adjust the intensity, now you can see the object stands out fairly well. So I'm going to go ahead and center on that object and create an observation after having loaded the star catalog, of course. So I now create the observation. Again, that's for the first 1/3 stack. Now I can do so again here. This is for the second of 3 stacks. And finally the last stack here. And so now I have 3 observations of the object. Again, this is 2005 QQ87. And what we'd like to do at this point is compare these observations with existing observations of the object. So these are the ones here, these last 3, as you can see, are the ones that I have just now generated. And these are the ones that were originally submitted using a different astrometry program. So we'd like to see how, performance-wise in the astrometry, where we are at with that. So let's go ahead and delete these, and that way we will look only at the residuals of that which has been submitted already. So what we're saying is we want to know as a baseline the astrometry that was originally submitted. So again, this takes a moment for find orb to find the solution here. So we give it a moment. And there we go. So C95 is the observatory code, and let's see if I can go ahead and put that into view here. So these 3 observations. So you'll notice 2.1 is the highest of these 3. So 2.1 and then a 1.7. So those are not terribly great, but I guess others had some issues with this object as well. The Z80 had a 3 and a 2. So anyway, so 2.1 and 1.7, and let's compare then with these newly generated observations of the object. So again, we'll give it a moment here, and it will find the solution, and then we'll be able to compare residuals. Okay, so now again C95, and as you can see, we now have a worst case scenario is the 1.6, so compare that with 2.1, and then 1.5 compared with 1.7, and I believe the other one had 1.2. So, but in any case, our worst residual and our second worst residual are better, for sure. And so we're certainly not doing any worse, and in fact I would say we are a slight improvement for sure. And as you can tell, this is certainly very quick to generate these observations, and the object certainly stood out quite well. So when I did these different stacks, so it's very quick, and I did not have to even run the tracker to do this. So that's the idea, is that hopefully we can solve these neo-CP objects more quickly. And again, this is in a very crowded star field, but nonetheless the object stands out very well using this ABV layer as compared with the average layer. So you would not have gotten good residuals with that. So anyhow, I hope this is informative. I'm not yet ready to release this version, but I'm working on it. So hopefully in the next week or so. Thanks.